atoms, they're losing electrons, creating the positive ions, and the non-metal atoms are creating the negative ions. The positive ion is called anion, and the negative ion is called, sorry, let me reverse it. The negative ion is called the anion, and the positive ion is called a cation. Okay. Now there will be a force of attraction between the two ions. So the examiner, how the examiner is going to mark you for this? The examiner is going to mark you for 3 points, which yesterday I have discussed with you, and those 3 points were, let me share with you those 3 points. Point number 1 is like the dot and the crosses, like oxygen, you correctly put the crosses and the dots, 6 of, and this one you need to put all the dots here. Okay. Or if you show it empty, no problem with that. It shows that it has lost 2 electrons. So 1 mark you will get for this structure, 1 mark you will get for this structure, and another mark will be for the charges. So you will get 3 by 3 for this. Okay. Now if we talk about the electronic configuration, magnesium is moving from 1s2 to 2s2, 2p6, 3s2. The 2 electrons from 3s are gone and they are taken by oxygen. Look at the configuration: 1s2, 2s2, 2p4. So 2 more electrons will be added to 2p, and then it will be 2p4. So the negative ions and the positive ion, they will start attracting each other, and this is the ionic bond actually. Then the ionic crystals. Ionic substances are making mainly crystals, and these are the joint lattices. This one is for sodium chloride, NaCl. Okay. There are 2 types of crystals of the ionic substances. The first one is called the face-centered cubic structure, and the second one is called body-centered cubic structure. Okay, we will talk about this a little bit. Body-centered structure and face-centered structure. This is very important, which we write NaCl, and the other is cesium chloride, CsCl. Okay. Sodium chloride is the face-centered cubic structure. Cesium chloride, where did I lose it? Cesium chloride is body-centered cubic structure. The coordination number here in sodium chloride is 1:6 or 6:1, and the same coordination number for this one is Cs and Cl. It's always 1:8, not the reverse. Reverse is not possible. And what's the reason for that? The reason for that is that sodium ions are smaller in size. It can accommodate chloride ions which are not that much bigger in size. But in case of cesium chloride, the cesium ion is much more bigger, much more, and you cannot even imagine. how much cesium ion is bigger. Cesium is very big in size as chloride ion. So here chloride is bigger, and on cesium chloride, cesium is bigger. When I'm working on the cubic structures right now, I'll tell you how these two cubic structures will look like. So focus on it, please. First of all, sodium chloride. Normal room in which you're sitting is just like a cubic box, okay? It has 8 corners, 4 at the top and 4 at the bottom. So I'm going to draw a structure. This is a box-like structure actually. 1, 2, 3, down, 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 and this. So you will find sodium. Keep in mind sodium is smaller than chloride. So chloride, chloride, sodium, sodium, chloride. Okay, this one sodium and here chloride. By face centered, I mean to say that if you open this box, one wall of the box is containing this. If this is the wall of the box, this is the wall of the box, and I remove this side, it's containing chloride complete and sodium complete, sodium complete and chloride complete. So if I remove this is the face centered. One face is containing all the ions which are essential for the structure. But when we talk about the body centered cubic structure, and the body centered cubic structure is just like you are standing in the middle of your room. Okay, imagine yourself. Cesium is in the middle of the room. That's you who is standing in the middle of the room. Now you have 8 ropes connected to the corners of the room. So 4 ropes will be connected to the top, okay, and 4 ropes will be connected to the bottom, because there are 4 corners at the bottom, or at the floor of the room there are 4 corners, and you're in the center actually. So how many? This is chloride, 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 and this is chloride. So if I want to draw a box-like structure, how will I draw this? Keep in mind, this drawing is not the part of the course, this is just to make you understand. And sodium chloride drawing is the part of the course. So let me draw a box. This is a box, okay? Keep in mind the box corners are not the connecting points like in sodium chloride. So in the middle of the box, this is the middle of the box. Cesium is there, right? Now cesium is in the middle of the box. The green line from each corner is the connecting point. So 4 connecting points, and you roped it and tied it up, and 4 connecting points are here. So there are no this sort of things in between. But again, it seems to be like a cube because it's a cubic in form. So if I want to take a slice of this, or I want to cut it into pieces, this structure into 2 pieces, I'll got 4 of the chloride on one side, 4 Cls, and half of Cs will be there with me. But in the other one, in this structure, no, it's not like this. Okay? Are we clear till this point?
Yes, sir.
Okay, my screen is not lagging, right? Are we clear?
Yes, sir.
Okay, now I'm moving towards now the properties of the ionic bonds are ionic bond. Actually, it's a strong electrostatic force of attraction between oppositely charged ions formed by the electron transfer. Now, ionic bond is having certain properties. Ionic bonding is stronger and the melting and boiling points are higher when the ions are smaller. Yesterday we discussed this point. Or having high charges. Like uh, if this is lithium with +1 charge on it, and fluoride you have seen yesterday's lecture also. So stronger force of attraction is there, much more energy is needed to separate them, right? In the same way, if you have magnesium with 2+ charge on it and oxygen with 2- charge on it, the charges are playing a very important role there. So there will be a stronger force of attraction between these two also, right?
Yes, sir.
Okay, now moving towards um, a little bit further, ionic radii. Now, this is very important now. We have sodium. When it loses one electron, it is Na with +1 charge on it, right? One electron being lost. So which one is bigger? Sodium is bigger or sodium positive ion is bigger? Sodium is bigger in size, and the radius of sodium is more than sodium +1 charge. What's the reason for that? Because sodium +1 means that it has lost one electron, one of the shell is also gone. If you see the configuration, it is 1s2, 2s2, 2p6 and 3s1. So the 3s is gone actually. Now there is a plus charge which is acting on 10 electrons. Before this plus charge was acting on 11 electrons. Now the force of attraction between the 10 electrons and the plus charge is more. That's why the size of sodium is less as compared to sodium. Okay, so positive ions are always smaller in size as compared to their atoms. Are we clear?
Yes, sir.
Okay. What about negative ions now? Negative ions are bigger in size as compared to their atoms. Yani if I take chloride, then chloride is much more bigger in size as compared to chlorine. And what's the reason for that? So Cl is gaining one electron. The gain of electron is actually giving it a repulsive force, which is increasing the size. So it was 1s2, 2s2, 2p6, 3s2 and 3p5. Now one electron extra is added, so the configuration is changed into 3p6 now. This one extra electron is coming to the negatively charged electron. There is a repulsion between these. So this will increase the size of chloride as compared to chlorine. Or the ionic radius of chlorine is smaller as compared to the ionic radius of chloride. So negative ions are always and always bigger in size than their corresponding atoms. Is there any question which you need to ask me here?
No, sir.
Okay. If it's clear to you, then I'm moving forward. This video will be uploaded inshallah on YouTube, so keep watching it then. Those who didn't subscribe me, subscribe me. Okay. Positive ions are smaller compared to their atoms. This is the conclusion. Because it has one less shell of electrons and the ratio of protons to electrons, I've already explained that to you, has increased. So there's a greater net force of remaining electrons holding them more closely. These notes will also be provided to you soon, inshallah. And then what about the negative ions? The negative ions are you see here, okay. The negative ions formed from groups 5 to 7 are larger than the corresponding atoms. Negative ions has more electrons than the corresponding atom, but the same number of protons. So the pull of the nucleus is shared over more electrons, and the attraction per electron is less, making the ion bigger in size. Okay. You can see the ionic radius now. When we are moving from nitrogen 3 plus to oxygen to fluorine and then neon sodium, you can see the ionic radius here, the bigger one for the 3 negative, then comparatively, and then comparatively. This is a comparison between negative ones, and see the comparison between positive ones. Sodium is bigger in size because it has +1 charge. The pull on electron is more. Magnesium with 2 plus charge, it has a 2 plus charge, so the pull on electron is much more. And aluminium with 3 plus charge, the pull on electron is much more. So that's why the ionic radius is being reduced here in this case. Now when we talk about the group, in the periodic table normal atomic radius down the group is increasing. The same is happening to the ionic radius, there's an increase down the group. And the reason for that is, as we go down the group, the ions have more shells, so more shielding effect is there, more number of electrons are there, so the ion is getting bigger